we move to the number 4. It's the last programming challenge for chapter 7, calculus problems. This challenge we will try to find the length of curve. So let's see from what's the meanings. So the length of curve is our given line, the curve that and give you 2 points. If you assume you are running on this curve and from A to B, so we are trying to calculate this one. So that is also the interesting the application from both the derivative and also the integral. So only after you learned the certain from the calculus knowledge, you can find this way. So in the left is on the mind map. Actually, I gave you our reference link for this one. There's many online resources and you can find this. I just gave you one reference from here. You can read from these LibreTexts about this arc length. So if you got time, I would like that you can read these through. So it's not only in the arc length. So in the two dimension, the space we are talking about, the problem is to make this arc length. If you have the 3 dimensions, you may also use the similar way to find the surface area. So our challenge here is only talk about the length of arc. So here is some just the logic, try to find out this the formula using the integral, the concepts. But finally, you can see here is the arc length is get this definite the integral, and on this square root here you see our derivative, and then this we have the square and with the dx. So that is the formula, and also we will use this formula directly, and then we see the y is the dy. This actually is the fx. So for our given the functions, we will use this then can find out the length of arc. So if you make further the reading, so here, so you can see arc length, you have some ideas. And what are about this area of surface? So that is, you can see is are the 3D parts, and you can also use the similar way to find the 3D. This surface area, and then finally the surface area you can see here is this part is similar, but we are adding something. Is you have make that into the 3D you times fx or times y, and with this 2 pi, because you have some circling this the rotating, then get this 3D surface. So if you learn this OpenICAD, actually you can draw the 3D with a more visualized way. Then you can show yourself on those. So, but that is not go for this topic. We don't go to that detail. So, the challenge, it just is try to write a program and to use this formula and accept one input function. Then we will try to calculate the length of curve. So from our the Python programming perspective, we need to get input our function, get input our variable, and do this integral derivative calculation, and output or print out the things. So it's quite a lot, so we can leverage from this challenge 3. So but we don't need the second function. So from that is let's start using this 3 and to change that to our 4. So that is also, I suggest, is our good practice. If you find is any existing program you built before, or fit some part of your new functions requirements, try to reuse. So even if you can promote some of your program to your self library or self class, then that will be more than easier to reuse. But that is the little more. We don't talk that for now. So length, if first is I rename this of curve, a curve. So we are not dealing with a tool. So then let's see. So our purpose now is different. Is finding the length of our given curve. So this given curve actually is just a function. So from the geometry part is a given curve. So we just need our first. So then enter the function in one variable. So and we have this variable. We don't need g. So but we still need a and b. So then we show this name is different. So it's the lower limit of the variable. So not the region. So. And the upper limit of the variable, so that on this shape will be the a and b, and we don't need to verify g. So your input function is so, and then variable is the still same, and we are not creating this area. So let's see the length. So what's the function? The arguments we have f, we have a variable, we have a and b. So we don't need this g. So we only need to print out length. Length between. So we can see here is length between length of function. So first let's output function and between a and b. So 2 is 3. So because those are the float, so whenever you have a float, is try to make that maybe I just 3f. Too long, and make that not too long. So function is fine. So now we should have a and b. So that is our main program. We already revised that. Then what we call is the find the length now. So we will revise this one, and we have just 4 arguments and not the area. So we will use this formula. So this formula we can write all, but here is we use this derivative. So we need to also load this derivative. And we have this square root. So let's make the square root. Otherwise, if you don't use this square root import, it will use the mass square roots that is not able to deal with the symbolic, the expression. So that's you need to pay attention. So we should have this, and we return length. And the first, let's create our. So here is the th. So if you don't see that in the same color, then that's you must have something. So now is you see the analyzing is not so fast. So derivative. Let's just see d is the derivative is the f. So we put is the f is our function and the variable, and with this dot, so we got this derivative here, and then we see the length. We just based on the formula, so is the integral. So integral in the outside. And here we have square root, and with our function. And in the last, we should have this doit. And also, we will generate this evaluate result. So we should have this evaluate f. So those part, and we are now talking on this square root is within that is 1 plus, we have this d with the squares. So and that is our first is the integrals expression. Then we will put our the lower and the upper bound here. So with this tuple, so it's the variable a and b. So that is the syntax. So let's do our testing. So enter the function. Let's enter this function 2 times x squared plus 3 times x plus 1. Enter the variable, definitely that's x. Enter the lower. So what's this lower point? To find the, let's see the point is, let's see what we will input. We should input only the x, so -5. B is here is the +10. Is getting length of function between -5 to +10 is 268. So if you check this from the solution paper, that's the correct result. And we will make another function test as mentioned here. So use this Cohen Academy. So it's x squared 3 divided by 6. So there's not x squared with this 6. So it's they have the first you have this power operation that divided by 6. So plus 1 divided 2 times x. So x is under this fraction line. So, and definitely a variable is x. And we have 1 and 2. So, and then the 1, 2, is 417. So that's correct. So actually, so you can continue enhance this one. Is I think it's not easy, not difficult for you now to plotting this this curve, and we also learn this how to highlight the curve between A and B. So in the one of the programming challenge earlier. So that's I think you may be enjoy on these results. So with this, the program challenge is we conclude this chapter 7. So first is thanks for your watching, and congratulations to together with me finish this. I should see that is challenging the chapter because this calculus sometimes is in some more the abstracting thinking or logic. But after all, we finished that. So in the next video, I will try to make our quick summary for the closing. And we already finished the key book contents. And I will try to select a little bit these key parts to demo from this appendix A and B. Some of them is we already talked, and I show you is in the different the linkage already, but some the points is valuable is we talk about a little bit so that you you can know is to emphasize certain parts and prepare you for the learning. So thanks again, and see you in the next closing video. Bye for now.